Okay, in the previous class we were studied about bottom chord member and top chord member. So now let us know how to design this inner chord member. As I've already told, for the bottom chord member and the top chord member we will be using a double angle section. But whereas for the inner chord member we use a single angle section. Here the inner chord member is DF. Okay, so the DF, the load is, the force of DF is 24 kilonewton, and we need to consider this as a tension member also and as well as the compression member also. Look at this, one is compression is the CF and EG. Which one is the CF and EG? CF and EG. CF is also inner chord member, CF and EG. CF is also inner chord member and EG is also inner chord member. When the CF and EG both are inner chord member, even FD and DG is also inner chord member. The value which they have given is CF and EG is minus 24 and the DF is plus 24. It means this is a tension force, this is compression force. Here you need to design, because both the values are same values, so you need to do you need to consider inner chord member as a tension force. You need to do a design for the tension force also and as well as to a compression force also. Okay, now let us know how to design this tension member, how to do this. So first let us do for the tension member design. So when you do tension member design, obviously you know the length also. Length is 4000 mm. Okay, and the maximum force it is given in the table, that is 24 kilonewton. When you convert that into ultimate force, so multiply with the 1.5, it means your ultimate force will be 36 kilonewton. So after that, design of tension member. For this you have a formula in the code book, page number 33. Okay, the formula, it is like this: TDN equals alpha AN into FUP by gamma M1. TDN is known value. Okay, so this is this ultimate force is there now, so that will be your TDN value, and alpha it is known always, it is 0.8, and AN you need to find out. FUP it is always standard 410, and the gamma M1 is 1.25. So when you calculate that, you will get your value as 137.195 mm square. Increase this value by 30%. So whatever you have got your area now, so you need to increase that by 30%. Okay, when you increase that value, you will get it as 1.78 centimeter square, you will get it. So based on this area, okay, what you have got 1.78 centimeter square you have got it now. Based on this area, you need to find out, you need to select an angle. So how do you select an angle? Actually I already have told, for bottom chord member and for inner chord member, always you need to select double angle, but whereas for the bottom chord and top chord member, but whereas for the inner chord member, based on this area, you need to select a single angle. Okay, so how do you select? From the steel table, near to the value which is near to this equal angle. You always you need to select an equal angle. Don't select, actually for the safer side, always you select an equal angles only. Okay, so for example 50 by 50 by 6, 70 by 70 by 8, in that way you can select it. Don't select 70 by 75 by 6 like that. Okay, so both the angles, that is length and breadth, should be equal. That is like this also 50 and this way also it is 50. In that way you need to select your angle. So when you select your angle, the value, the area of that angle should be near to this value or greater. It can also be greater than that. Okay, when you select your angle, so you have selected this angle 50 by 50 by 6 mm, right? So in that, from the steel table, the area for this particular angle. Okay, sometimes it is better to choose greater than that. Okay, like for an example, here the area was 1.78 centimeter square, right? Here the area is 5.68 centimeter square is there. Okay, based on this CXX, you need to take out CXX value also. In the steel table it is there, check out in the steel table. Even the EXX also, that is eccentricity at the X distance, and CXS is centered distance. Okay, so actually for an example, suppose here is one angle is there, so length is this one and the breadth is this part. Okay, so you need to give a connections. For that connection, so suppose there is a bolts are there, so okay, the force which is away from the the force which is away from the distance as CG, okay, center of gravity. So this we call it as an eccentricity, right? The force, suppose the force is acting over here. So this is your center of gravity, that is your neutral axis. So it means the force which is away from the neutral axis, we call that distance as eccentric distance, okay. So in the same way here, this part is Exx and this part is Cxx, okay. So for that reason you need to take your Cxx value also and the Exx value also. Check out this. Now here actually you can do any connections over here, okay. Either you can do a bolted connection also, or you can do a welded connection also. Actually in the bottom chord member and the top chord member you have studied about this bolted connection. So for a change I have chosen this welded connection over here. So this is your angle. This is your gusset plate, okay, and the angle is what angle? It is 50 by 50 by 6 mm is there, and look at this distance, the force which is acting here, this is the force, okay. So force is acting at the center. So suppose this is on a neutral axis, okay. So this is Exx and this part is Cxx, okay. So you check out this Exx value is 3.55 centimeter in the steel table, whereas convert that in centimeter into a mm. So this will be 35.5 mm and this is Cxx is 14.5 mm. So after this calculate the size of the weld, okay. So to find out that size of the weld, the formula is, actually it is a standard formula. Force strength of the weld F equals 0.7 into S into L into FUP by square root of 3 gamma MWO. This L is there, no? This L is there, no? This L is nothing but total length of the weld. So it means capital length L equals L1 plus L2. This L1 and this L2, okay. So total together we call it as a total length of the weld. So S is whatever the S is there, this is nothing but size of the weld, okay. So size of the weld formula is 3 by 4 into thickness. Thickness of what? Thickness of your angle, okay. So here you have taken now thickness of the angle, so this is 6 mm, right. So thickness of the angle you need to substitute over here. So when you substitute that thickness of the angle, you will get your value as 4.5 mm, round it off into 6 mm. It is just because minimum size of the weld should be 6 mm, okay. Minimum size of the, anywhere, wherever you study, minimum size of the weld should be 6 mm. So hence the size of the weld is 6 mm, okay.